see that. All right, here we go. Now, for question number 2. All right, what we do is we say that it is not possible to divide a rational number, which is 5. 5 is called a rational number. 6 is called an irrational number. So what we're trying to do is we are trying to eliminate the radical that's in the denominator. Now, again, I've never had a clear understanding of why this is necessary, but the mathematicians got together and they said you're just not allowed to have a square root in the denominator. All right. So because you cannot have a square root in the denominator, we are going to eliminate that. And how we eliminate that, we say we rationalize the denominator. So to rationalize the denominator, all you have to do is multiply by whatever the denominator is. So in this case, we would just be multiplying the top and bottom by the square root of 6. And we multiply the top and bottom by the square root of 6, we end up with 5 radical 6 on the top. And just what?
1 on the bottom.
6 on the bottom. All right. Now, if it's possible, you can reduce the fraction, but 5 and 6 obviously don't reduce. So that is your answer. That's all there is to it. It's called rationalizing the denominator. All right. You're eliminating the square root that's in the denominator. Number 4. All right. We're multiplying the top and bottom by what? Yes, we're multiplying the top and bottom by radical 7. So it ends up becoming 21 radical 7 over what? Over 7. All right. Now, as I was saying before, now is it possible to reduce the 21 and the 7? Yes. All right. So that's why it would be 3 radical 7. Now remember, just go with me. Don't try to be a step ahead of me and try to tell me the final answer. I don't care about the final answer. All right, we're doing it step by step. All right, anybody have any questions? Now remember, I'm trying to teach you before you go. It's much better to ask questions before we get to the hard ones. Anybody have any issues? All right, here we go. Number 6, we're simply multiplying the top and bottom by. So here we go, multiply by radical 6, radical 6. Now, again, distributing the square root of 6. Can I multiply the 5 and the 6 together?
Yeah.
The answer would be no. One's rational, one's irrational. All right. So when you multiply, you'd have to say that's 5 radical 6. Now, everybody's going to tell me radical 6 times radical 6 is just what? 6. All over 6. Beautiful. Now, my question to you is, can I reduce this 6 and this 6? Things bounded by addition and subtraction cannot be reduced. So make yourself a little note of that. This right here, these two things are bounded together by addition. So we are not allowed to reduce the 6. If it was just multiplication, you could reduce. But the 5 radical 6 and the 6 are held together with addition. Therefore, you cannot reduce. What?
I don't really understand. So once you have 5 radical 6, which I understand, and then where's the next 6? Sometime where it's just
What is radical 6 times radical 6? There you have it.
Isn't that how you did the first one? The first radical 6?
You have to think back to yesterday now. This is a binomial. And this is a monomial.
Okay.
Right?
Yeah.
All right, thank you. All right, anybody else? All right, I'll see how we're doing. Multiply the top and bottom by? Yep, radical 13. So the top becomes 7 radical 13 plus 13 all over. Can I reduce anything? No. Anybody have any issues? All right, let's take a look at number 10. Multiply the top and bottom by? Here we go. Radical 6. So what's 3 radical 6 times 6, everybody?
8 would be 18.
18. Because again, radical 6 times radical 6 is 6. 6 times 3 is 18. Now, what's radical 6 times negative radical 5? Negative radical 30. All over 6. There you have it. Can you reduce that? No, bounded by addition and subtraction. Now, we always want to reduce or simplify if we can. So now everybody should be able to tell me after a couple days, you should be able to look at 18 and just tell me that's what, Alden? Thank you, Alden. 9 over 3 radical 2. All right. Come on now, think it through before you ask. Square root of 18 is 9 times 2. Square root of 9, 3. What?
I thought you couldn't have a radical as a denominator.
I didn't say we were finished at all. All right. Now, is it possible to reduce the 9 and the 3 here? Yes, it's all multiplication. So now I have 3 over radical 2. Now I just multiply the top and bottom by what? There you have it. And so my final answer is 3 radical 2 over 2. All right, it's a lot more difficult if you just do radical 18 and radical 18. Always try to simplify the fraction. All right, here we go. So 45, everybody should be able to look at 45 now and just say that's. Thank you. 3 radical 5. That is correct. And then we reduce to what? 2 over radical 5. Perfect. And then multiply top and bottom by. Final answer. Yeah, I'm telling you guys, it really is truly that easy. Anybody have any issues? All right. 16, what should I do first? Yeah, you want to try to simplify so that I can reduce by what?
To 2/3.
So we're going to say 2 over 3 radical 3. Everybody good with that?
Multiply the radical 3. We get 2 radical 3 over 9.
All right. Anybody have any questions with that? All right, here we go. Okay, so now it's just extra practice, okay? All right, I just mixed everything up. All right, I just mixed everything up. So now, come on now, we're practicing. Everybody's got to see these. All right, here we go. What is radical 7 times radical 7? 7.
7 radical.
What is
4.
the square root of 4?
2.
2. 7 times 2. 14. Anybody have any questions? All right, now here. What is this?
2, 3, 3, 4.
What's 12 divided by 4? 3. Now we look at this. What does that reduce to? Yes, just radical 4, right? And now, what is square root of 4? So the final answer is just 6. Are we okay with it being 6? All right, here we go. Now, again, this is a nice problem here. All right, so please listen. 3 times -5. -15. What does everybody see in here?
10.
A 7. So times 7. What's left behind in this radical?
4.
And now what's the square root of 4?
2.
2.
-50.
Now, again, just listen. If you're not sure about that one, I think that one's pretty hard. Does anybody need me to repeat it? 3 times 5 is what, Oscar? What's common with 7 and 28? Right? Do you see it now? So the final answer should be like -210. That was pretty tricky. 24. What is that? What?
3 radical 5.
3 radical 5. Okay. Now we just did 28, so that should be pretty easy for us. Square root of 28 is what? Right? And then, but remember, it's just 4 times 7. So what's the square root of 4? So that comes out as a 8 radical 7. Now 112. I told you, right? One of the biggest helps is understanding the previous problem had a what in it. So the other one's probably going to have a what? 7. So now most people don't know 16 times 7 is 112, but we were able to say divide it by 7 because there's a 7 in the first part. So you're hearing me on that, right? So that's 16 times 7. And what's the square root of 16?
4.
When you see a 6 out in front,
So it'd be 24.
right, plus 24 radical 7. And now 24 plus 8, 32 radical 7. All right, now, like I said, as we're going down, you know, you're supposed to be getting some practice. All right, understanding. Tell me.
So is the only, like, on the one, on number 22, you multiplied the 3 times the -5 first, but on this one, you did the radical. This is just like, there was an extra step.
I'm not multiplying here.
Or-
I'm adding.
Well, number 22, 3. You did
I'm
3
multiplying. There's a big difference. This is a multiplication problem.
Yeah.
This one is not. This one's an addition problem,
Oh,
right? That's the main difference. All right, here we go. 28. Now it's hard to look at 242 and say, what's the perfect square, but what goes into 2, 4, and 2?
2.
So I know it can break down to 2 times something. When we look at that, we say 2 goes into 242, 121. And I can say, okay, that's pretty good because I know the square root of 121 is what? 11. So that's 11 radical 2. Now I'm looking at 363, 3, 6, and 3.
3.
Right, so that's 3 times what? 121. And then
So
what
nine-
is
nine?
the square root of 121? 11. Now, does everybody see a 3 out there? Does everybody see a 3? So what do we do?
So 33.
Yes, so that's minus 33 radical what? 3. Come on, just stay with me. All right, you're following me step by step. Anybody have any issues with that? I don't, you're interrupting me. Go, that's why I don't, when people need to use restroom, just don't interrupt me.
Every other class.
Shh.
makes this.
No, I don't care what every other class is doing. You're interrupting me now too. I don't like to be interrupted. All right, where are we at now? I was interrupted twice.
Yes.
So is that an answer? Or is there anything I can do to that? What can I do, Oscar?
You can divide the 11.
What are you talking about dividing?
The radicals aren't the same.
The radicals aren't the same. Beautiful. That's a great explanation. The radicals are not the same, so that's the answer. You cannot add or subtract those because the radicals are not the same. 11 radical 2 and 33 radical 3 have nothing to do with each other. All right, they're completely different numbers. You can only combine when they're exactly the same. Anybody have any issues? Okay, here we go. Number 30, simple, simple. Just doing what?
There's nothing to do, so we just times it by
2
radical
radical
7.
7 over 7.
Yep, just multiply the top and bottom by radical 7. So that becomes 2 radical 7 over 7. All right, easy. Let's check out 32. All right, seems a little bit longer, but it's not. All right, square root of 63 has what in there?
There's a null in them.
7 times 9.
Right, 9 times 7. So then the 9 comes out as a what? 3, because there's a 3 out there, it just becomes 9 radical 7. Here I have radical 28. So that's what? 4 times 7, square root of 4 is, when I multiply, right, plus 4 radical 7. And now, how many quarters in 175?
Well, you know it's something times 7.
So how many quarters are
That's
there?
going to be 25.
That was your clue, 25 times 7. What's the square root of 25? So there you have it. So what do I have?
You have 8 radical
8 radical 7.
No, I didn't.
Anybody have any issues with that? All right, and again, hopefully you're understanding what I'm saying is, once I break this down to 7, generally there's a 7 in the other ones. Not always, but a lot of times. All right, here we go. Now we're just multiplying. All right. So what is square root of 6 times square root of 6? 6. First smiley face, what is that?
plus radical 30 minus radical 30.
What are you doing? Just
Maybe plus 5.
listen, all I want you to do is when I ask you a question, just answer my question.
Okay, well then,
All right. The first smiley face that I did on the board.
that would be 6. Okay, then negative 5 times negative 6, that would be minus radical 30.
Yes, negative radical 30. All right. The next little smiley face is going to be positive radical 30. And then 5, radical 5 times radical 5 is 5, but keep in mind you're doing negative times a positive. So it's minus 5.
It's just
But
gonna
the
add
thirties
one.
cancel.
And then the middle terms here happen to cancel out. You are correct. So then it's just 1. That's how simple. All right. Here we go. Now, I like to tell kids to just go ahead, let's white this out. And then 4 plus 2 radical 5. Come on now. Everybody give it a shot. All right. Everybody should be able to tell me 4 times 4 is 16. This is
Would that be 8 radical 5?
8 radical 5.
And then another 8 radical 5. Then that be-
Now, everybody's got to be careful on 2 radical 5 times 2 radical 5.
Would it be 20?
All right.
It would be 20, right?
So again, 2 times 2. And then radical 5 times radical 5. So 2 times 2 is 4. Radical 5 times radical 5 is 5. 4 times 5 is 20.
Okay, and the
All right.
36 plus 16.
And now again, we're just adding like terms. So you're adding the numbers together and you're adding the radicals. Anybody have any issues? Pretty easy. All right. Here we go. Now, again, for number 38, the first thing I'd want you to do is I'd want you to look at the 14 and the 2 and just reduce that to 7 over radical 7. And then we're going to rationalize.
Do 7 radical 7 over 7.
And then you end up with 7 radical 7 over 7. And then, of course, we can reduce. So your final answer here could just be what?
Radical 7.
Radical 7. That's not bad. All right, and then 40. Okay, this one looks kind of tricky. So let's really concentrate here for a second, because I really don't want to do 5 times 75 and then break it down. All right. This 5 has a common 5 in here also, right? So 75, I just want you to think about is 5 times 15. So now when I multiply those together, this 5 and this 5 comes out as a what? 5. And there's already a 3 out there, so that becomes 15 radical 15. Now, does anybody need me to repeat that? Who said yes? Okay, so what's the problem you're having with 75? With I can't hear you. Well, what's radical 5 times radical 5? Radical 5 times radical 5, you said was what? No, would be what? 5. Right? So how did I get 15? There's a 3 out there, am I right? So what do you think you do with the 5 and the 3? All right. Now, over here, with the 5 and the 12, is there anything common with 5 and 12? No. However, all right, there is in 12, there's a perfect square. What's the perfect square?
4.
4. So this, I want to make sure I'm clear, is 4 times 3. What's the square root of 4?
2.
2. Now there's a 2 right here, correct? So that's a 4. So if I wanted to, I could have written this as 4 radical 3. Sorry, guys, for the disturbance. And then 4 times this 3 times this 4 now is what?
Oh,
12. So that would be negative 12 radical 15. And so what's 15 radical 15 minus 12 radical 15?
3 radical 15.
3 radical 15. Okay, so that was really hard, actually. If you understand that, then you understand everything. All right. Let me just go back one more time. All right, I'm going to redo this one just to make sure. All right, I was clear. All right, let's look at it one more time. Try to concentrate now. All right, I'm looking at them separately. And I notice in 75, there's a common 5. So the first thing I did was I just made that 5 times 15. Now when I multiplied this radical 5 and this radical 5 becomes what? 5. And then there's a 3 out here. So 5 times 3 is, so now I knew that multiplied together was 15 radical 15. All right, now what I'm doing is I'm going to multiply these two things together, the 3 radical 5 and the 2 radical 12. And I said, well, there's nothing common with 5 and 12, so I can't break it down. But I do notice that in 12, there is a perfect square. 12 is 4 times 3. So then I said, what is the square root of 4? And then there's a 2 out here. So the first thing I did was I looked at that and said, well, that's just negative 4 radical 3. Now what I'm doing is I'm multiplying the 3 radical 5 times the negative 4 radical 3. And that's how I got negative 12 radical 15. And then 15 minus 12, 3 radical 15. All right, like I said, I think that was pretty hard. All right, what's next? Oh, that's nice. All right, that's good for us. Okay, so now what I want to do is